Let's look at how we can solve quadratic equations. That means they're in the form ax squared plus bx plus c equals 0. That's a second degree equation by completing the square. For our example, we'll use x squared plus 6x minus 11 equals 0. So the ax squared is the x squared, the bx term is plus 6x, and the c term is negative 11. The first step is to make sure the coefficient of the ax squared, or first term, is 1. So the a value is 1, and by that I mean positive 1. You don't want negative 1. And if it isn't, we're going to have to divide or multiply by the reciprocal all the terms of the equation to make that happen. It's got to be positive 1 for the coefficient of x squared. Hey, it is for us already, so we don't have to worry about it in this example. Next, we're going to rearrange the ax squared plus bx terms so that they are alone on one side. Right now all the terms are on one side. This c term, the constant term or the free number, it doesn't have any variables attached, needs to move over to the other side. So we'll add 11 to both sides, and now the ax squared plus bx terms are by themselves on one side. That gets us ready for the next step. It's also a good idea to be ready for the next step by leaving some space because we're going to be adding numbers. All right, we've got some squares here showing us where we're going to work on finding another number to add to both sides. We'll do it by completing the square on the left, and then we'll have to balance on the right. So, we've done this before. We'll check out the coefficient of the middle term. It's positive 6. We'll take positive 6 and divide it by 2 to get positive 3. Square positive 3, and that gives us positive 9. That's the number we're going to add to both sides, and it should be positive. So there we go, popped in plus 9 on both sides. Sorry about the unnecessary rectangle that just showed up around all of our work. So there we are so far. I'll combine like terms on the right. 11 plus 9 is 20. And now we've got to make a binomial square on the left. X squared plus 6x plus 9 is a perfect square trinomial, and it factors into x plus 3, that whole quantity squared. And we've solved equations like this before. So we've now completed the square on the left, balanced on the right, and we're ready for the next step. Take the square root of both sides and solve for our variable. So we'll take the square root of all of x plus 3 squared and the square root of 20. That left side just turns into x plus 3. The right side, remember to use plus minus, is plus or minus 2 square root of 5. We want to get x by itself, so we'll take this plus 3 over on the left, subtract it from both sides so it shows up on the right, and we'll get x equals negative 3 plus or minus 2 square root of 5. Those are the solutions. I was going to try to circle them for you, but I had trouble because of this rectangle. But those are the two solutions that work. If you plug those in for x and go through all the work of foiling and distributing, it does work. Actually, both of those work. Negative 3 plus 2 square root of 5 and negative 3 minus 2 square root of 5. You try this one. With some help here at the start, it might look pretty bad. 4m squared minus 48m plus 112, a triple-digit number, equals 0. But you need to remember our first step. The first step means that we need the coefficient of that squared term to be positive 1. And it's not. Take a couple of seconds to think about what we need to do to get the first term to be positive 1. We've got to divide all the terms by that value. So we'll divide everything by 4. And now, m squared minus 12m plus 28 equals 0 is ready for step 2 and for you to try to use completing the square. Go back and look at some of the video if you need to remember the steps and see if you can get a correct solution. Actually, 2 correct solutions, because you'll have a plus and a minus.